Today we'll be looking into gas hydrates. My name is Kian and my group members are Yong, Yong, Daniel and Martha. The objectives for today are firstly the introduction, what are gas hydrates, where are they located and how are they formed. Next will be its working principle and energy conversion. Then will be its advantages and disadvantages, and lastly the conclusion and some recommendation. So, what are gas hydrates? Gas hydrates are solid ice-like form of water in which gas molecules, such as light hydrocarbon molecules, are embedded into its molecular cavities. The most common naturally occurring gas hydrates are forms of water ice which contains large amounts of methane gas within its crystal structure. They are usually found under depths of 2,000 to 4,000 meters below the crust, as well as the uppermost solid mantle of the Earth. They are also usually found in compositions of 1 mole of methane to 5.75 moles of water. So where are gas hydrates located? There are only 4 suitable conditions on Earth that allow the formation and the stability of methane hydrates. They are, firstly, under the Antarctic ice, second, sedimentary deposits along coastal margins, third, sediment units beneath the Antarctic permafrost, and lastly, deep water sediments of inland lakes and seas. So how are gas hydrates formed? When non-stoichiometric or small gas molecules and water comes into contact at low temperature and high pressure, gas hydrates are formed. The gas hydrates then solidify at low temperature and agglomerate to a compact cluster. Next will be its working principle and energy conversion. There are 3 main methods of extracting gas hydrates, all 3 having its own drawbacks. The first method is thermal injection, and its drawback is large heat losses and economical loss. The second type of extraction is inhibitor injection, having its drawback being the cost of methanol and ethyl glycol. And the last method is depressurization, and its drawback is endothermic nature, which may cause drop in reservoir temperature. Next will be the method for energy conversion using gas hydrates. Firstly, convert gas hydrates to energy that can be used by using combustion. Next, by burning gas hydrate, methane gas inside will be converted to carbon dioxide, water, and a great deal of energy. The carbon dioxide converted from the gas hydrate is more efficient than other hydrocarbon as it releases lesser harmful gases. Next is the advantages of using gas hydrates. Firstly, it's an alternative source of energy for gas flaring. It can be converted and stored effectively and efficiently as gas hydrates, and is a source of renewable energy. It has an effective and cheap means of transport, as natural gas in forms of hydrates can be transported without the cost of compression. And lastly, the amount of energy found in gas hydrates is a lot compared to all the world's oil, coal and gas put together. Next is the disadvantages of using gas hydrates. Firstly, it is difficult to find an economical way to obtain gas hydrates. Hydrates may dissociate upon recovery, acting as an engineering problem. Next, large expenses are required to transport hydrates through a long pipeline across continental slopes. These pipelines may be subjected to blockages. Next, it is difficult to locate using seismic methods, as it may affect the stability of seabeds, causing it to collapse if not extracted carefully. And lastly, methane gas could be released during extraction process. Methane hydrates starts to become unstable and methane will be released. This will increase the amount of greenhouse gases, posing as a problem for climate change. Methane gas is also 30 times more damaging than carbon dioxide. Lastly is the conclusion and recommendation. Firstly, gas hydrate contain large amount of natural gases, which is too much to ignore. However, it is still not highly recommended to use gas hydrate, as the cost and risk of extracting it is very high. It also poses as a major threat to the climate and may contribute more to global warming as when the extraction is done improperly. During combustion, the hydrate still releases carbon dioxide, but is much cleaner compared to burning coal or oil. More innovative technology and deeper understanding is required for exploitation of gas hydrates to be developed. That's all from us. Thank you.